For instance, I have 6 ring point, 6 ring circuit. If I have 6 ring circuit, so 2 circuit should go to one line, 2 circuit again should go to another line, 2 circuit again should go to another line. That is the arrangement of distribution board setup. Okay, let me show you again. Now, for instance, I have this as my distribution board, right? So what that implies is that, for instance, let's count total star block here, total final sub circuit we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, we have 18 here. For instance, if we are using this particular arrangement of dB, this is 18 here. 18 plus 18, we are having 36. So we are having total of 36 final sub-circuit in this distribution board. I just give example, but we are not going to use this arrangement. Okay, we are going to use this dB. The reason is because number of pipe that this can accommodate cannot give us this, because we don't want to run pipe unless we are using up and down arrangement. If some of the circuit will come from under and some are coming from up, that is when we can use this. But if we are using only up, we cannot use a dB of this kind. What I mean is this: if we are going to do the installation such that some of our circuit entering the dB, some of the pipe will come from below here, some of them will come from up. Okay, so we can afford to use this type of distribution board. All right, that means some of our circuit arrangement will come from underground. We are using floor method, the floor piping method. So we're going to use floor for the ring, some of the ring circuit. So in that case, some are coming from down. Then lighting circuit should come from up. Lighting circuit and some of the power circuit will come from up entering. Then ring circuit come from down entering. So in that case, we can afford to use this type of dB. Okay, but if we are using only up entering, this one cannot accommodate the whole of the piping system that we take this circuit, because we are having 36 total final circuit here. Right? Okay, those of us that are familiar to installation of buildings, we understand this narrative. But if you are not familiar to installation of building, this discussion we have a little issue understanding what I'm trying to explain. But as we progress, there is not an issue. You understand it more better. All right, so let's go back to the floor. Okay, so we are going to use this particular requirement to do our calculation. Then for the lighting circuit, okay, we're going to use 100 watt for each of the lighting points. Come back here. Each lighting point here, we're going to use 100 watt, okay, for our calculation. Then we are going to also apply 1.8 factor. This factor of 1.8 is the factor set aside to add allowance for a certain category of lighting system, such as discharge lightings, fluorescent, energy saving, LED, and shocks. Okay, any lighting system that uses shocks and the igniter and capacitors, these are the categories of lighting system that fall into the factor of 1.8 in order to augment the starting current of this lighting system. Okay, that is to augment the power losses from the switching systems. Okay, all right, so we're going to add this to give allowance for what I've just explained. Then we're going to add from the categories of we're going to use a diversity factor. So that diversity factor will fall into 75% for the lighting. Okay, let me show you the table for our diversity factor table. This is the table. Let me adjust it. This is our diversity factor table. So because we are working under commercial, this is under commercial, small hotel, boarding houses, guest houses. So this is the column that we are going to use. So the lighting For us to apply diversity factor under lighting, we are adding that we're going to use 75%. Okay, 75% is the total allowance of the lighting system we are going to use. Okay, supposing I have 5 circuit in lighting circuit, total lighting circuit of 5. I'm going to take 75% only out of that total circuit. So 25% is going to be diversified. It is assumed that the total light is not going to be on simultaneously. So because they are not going to be used simultaneously, it is assumed that 75% of the total lighting system of the installation is going to be utilized. Then 25% is going to be off at every given time. So that is what diversity factor implies. Diversity factor, we are using diversity factors to assume that the total load demand of the lighting system, 75% is going to be utilized on a regular basis. Then 25% is going to be diversified, going to be off on a regular basis. So I don't know if you understand this narrative. So we're going to use 75%. We're going to apply 75% to our calculation. All right, that is for lighting circuit. Okay, then for socket, we are going to come here, and if we are choosing standard, we are choosing that of ring circuit. We're going to use this. So you're going to fall under 100% for the first circuit, then 50% for the second circuit, then the rest is going to be rather, if we are using this, we're going to use 50%. Then if we're using this column, we're going to use 100%, but we're not using this. So what I want us to do is we're going to use this under this 50%, or we can as well change the circuit arrangement to use that of this a third radial. If we are using that, so in that case, we're going to use this circuit, this column. If we're using this column, so we're going to fall in here. So if you're not using that standard arrangement, we're using the second and the radial. So we're going to use this 100% for the first circuit, then 75% for the second circuit, then the rest will be 40%. Don't worry, by the time we apply the diversity factor, you know the formula more better. All right, but this is the column we're going to use for our calculation. Okay, all right, so let's go into the come back to this table. So we're going to size the whole of this using the whole of what I have just explained. All right, so let's go into the calculation.